Okay, this is a classic tricky question, but don't worry, we'll do it together. And the reason why this is tricky is because we are given a graph of the derivative, but all of the questions are asking us about the original. Once again, this right here is the derivative, right? This represents the graph of the derivative, but all of the questions are asking us about the original. So we really have to remember the connection between the derivative and the original. First of all, we are looking for the interval that f, this is the original, that the original is increasing. Well, we are given the derivative only. How can we make the connection? Here is the deal. We know if f prime, namely the derivative of the original, if this is greater than 0, then the original function f is increasing, right? So we are looking for where f prime is greater than 0, and when we are given a graph, this is what we can do. Keep in mind, anything that's above the x-axis has positive value, and anything below the x-axis has negative value. So we're looking for the place that the graph is above the x-axis so that this will represent positive derivative. Once again, this right here is the derivative graph. So in order to find out where f is increasing, we are going to look for the place that the graph is actually above the x-axis, namely this part, right? So it seems that we have from 1 to 5. And let me just write it down with interval notation from 1 to 5. And we don't include the endpoints because at here and here, the derivative is 0, so it's technically not really increasing over there. All right, so that's pretty much what we can do. All right, similarly, we're looking for the interval where f is decreasing. And in this case, we're looking for f prime is less than 0 because this will imply that the original is decreasing. So I'm looking for a place that we have negative derivative, meaning anything that's below. So we have this part and that part. This part is from 0 to 1, and then the other part is from 5 to 6. So put on union 5 to 6, and then we are done, right? So this right here is the deal. Now let's do part B. And part B is about finding the local minimum of the original function and then finding the local maximum of the original function. So once again, we really have utilized the derivative right here, okay? And recall that from the first derivative test, if we have f prime, which is the first derivative, if this changes from, if you want to have a local minimum, you want the f prime to change from negative to positive. Because if f prime, it goes from negative to positive, that will tell you the original function goes from decreasing to increasing, then we will have a local minimum. So negative to positive, so it seems it's right here, right? Because this portion, we have negative derivative, and then this portion here, it becomes positive derivative. So it seems that we have at this point 1. So it has a local minimum at, oops, I have the add already, at x is equal to 1. So it goes from negative to positive right here, and it happens to be 1. And the derivative at 1 is 0, and you get a critical number. Next, f has a local maximum. So for this situation, we're looking for the case that f prime changes from positive to negative. This right here is perhaps one of the most common mistakes because people see local maximum and then they just go ahead and pick the highest point right here. That's not the case because this right here is asking us about the original function f, but we're given the derivative. You must utilize this idea here. We are looking for the place where f prime changes from positive to negative. Positive is up here, negative is down here, so it happens right here when x is equal to 5. Right? The derivative changes from positive derivative right here to negative derivative. Right? Positive derivative to negative derivative at 5. And this right here is it. Now, concave up, concave down situation. How can we find f prime? How can we find f? The original is concave up. Well, we have to utilize the second derivative, right? This means, let me just write this down right here. We need to have f double prime to be greater than 0. This will tell us the original function f is concave up. But I don't have the second derivative right here. This is only the first derivative. But it's okay, because remember, this right here, f double prime is just the slope of the first derivative, isn't it? Therefore, I'm looking for the place. I'll put it down right here. I'm looking for the interval so that the slope of f prime, right? The slope of f prime is greater than 0. This right here is the graph of f prime. And we're looking for the slope of f prime is greater than 0. Now you see, this portion from here up here, it's going up. F prime is increasing. I'm saying f prime is increasing. I'm not saying the original is increasing. When f prime is increasing, that will tell you the original f is concave up. On the other hand, I want to find f is concave down. Then we just do the slope of the f prime, and we are going to utilize the graph again to be less than 0. Meaning that I'm looking for the graph of f prime to be going downward from here to here. So 3 to 5 then, right? 3 to 6, sorry, 3 to 6. So I put this down in red, 3 to 6, like that. Lastly, I'm looking for f has a point of inflection. Where do we have a point of inflection of the original function f? Once again, this is a really common mistake because people just look at the graph and you see it seems like it's always concave down. But remember, this right here is the graph of the derivative. But our question is asking us about the original. So we have to utilize the idea again, all right? So f has a point of inflection. The situation is where the second derivative changes sign, right? F double prime changes sign. Meaning that you can go from negative second derivative to positive second derivative, or positive second derivative to negative second derivative. And once again, we don't have second derivative, but it's okay. This is the first derivative. We look for the slope of f prime. This is how we get the second derivative. Slope of the f prime. And the reason I say slope is because, once again, we can utilize the graph. Slope of f prime changes sign, right? And now, as you can see, the slope of this graph, the slope of, which is f prime, right? It's positive. And then we hit 0 right here. The slope right here is 0. And it goes down. So that's x is equal to 3. And we are done. F has a point inflection at x is equal to 3. All right, so hopefully this helps. And maybe you want to rewatch the video again or so, and just kind of pay close attention to this type of question. When you are given the derivative, you have to think really, really carefully, right? That's it. And you can check out my other video. I will do more example about this for you guys. That's it.